Hello everybody, so in this video I'm going to be going through the graphs and transformations for Excel, which is chapter 4 for AS level and the full A level mathematics specification. Okay, so we want to get right on with our prior knowledge check, as I have for every video in this section. So, factorise these quadratic expressions. So Part A, we've got x squared plus 6x plus 5. Nice easy factor there. We've got x plus 5 as a factor. Then you can use polynomial division to find the other. Or you can have a pretty good guess. Is x plus 5 times x plus 1. Okay. Which is what I've got there in red. So we've got x squared minus 4x plus 3. So we want factors of 3 that add to minus 4. So you've got minus 3 and minus 1. Yep. There we go. Sketch the graphs of the following functions. So we've got y equals x plus 2 and x minus 3. Graphing that, you want to find what shape of the curve it is, the roots of the curve, and where it crosses the axes. So these are the roots where it crosses the axes. Solving this equation equal to 0. I'm finding the minimum point, which is here. Okay. And then finding this part by expanding this out. The 2 times the minus 3 would give you the positive, so it'll be x squared. It'll be a plus 2x and a take 3x, so it'll be minus x minus 6 for my function. Okay, that's the equation. So just expanding multiple brackets out, so the reverse of part 1. Okay. So nice easy quadratic there. So, next bit. I have to work a bit harder on, because I have to factorise it first and find my factors. So let's do that and do the quadratic formula as well. So we've got x plus 1 as a factor, and I have x minus 7 as a factor. Okay, expand that out, you'll get the x squared minus 6x minus 7. Okay. And obviously it's the same as what we've done in the first one, but it's just sketching the quadratic graph. Okay. Nice and simple. Part 3. Copy and complete the table below and use it to plot the graph of y equals x cubed plus x minus 2. So it's a cubic graph here. So what I'm going to do is spin all those numbers straight into the equation. I've already done these previously just to save a bit of time. So when I sub in minus 1 I get minus 4. Sub in minus a half I get minus 2.625. Now sub in 1 I'll get 0. 1 cubed plus 1 is 2, take 2 is 0. And 1.5 I will get 2.875 there. Okay. And that's how we can do that. So that's the first part of part 3. Then to draw the curve, it's a cubic, so it is going to have a stationary point, which you could do by differentiation if you know how to do that. So you can quite easily find that, and that is the sketch of the curve. Now part 4, solving these simultaneous equations. Well, the first one I automatically want to substitute in. So we know what y is, I can sub y in there, so I get x plus 2x is equal to 6, so I get 3x is equal to 6. So dividing both sides by 3, I get x is equal to 2. Subbing that back in, I get 2 lots of 2, so that implies that y is equal to 2 lots of the 2, which is 4. Okay, that's what we get in red there. Next bit is we've got y equals x squared and 2x minus 1. So we know they're both equal to y. So I get the x squared is equal to the 2x minus 1. So I get, what do I get there? X squared minus 2x plus 1 equals 0. Okay, so I get x is 1 and y equals 1 as well. Alright, so the brackets would be x minus 1. Yeah, and x minus 1. And you sub that back in. So 1 squared is something like that. Okay. So, moving on to cubic graphs, which is the first part of the new bit of work that we will do. Okay. So, cubic graphs are of the form f of x is equal to ax cubed plus bx squared plus cx plus d equals 0, where a, b, c and d are real numbers and a is non-zero. Okay, so first thing, if a is positive and if a is negative, we get those two shapes. So if we got a positive coefficient of the a, alright, the graph will start in the bottom left and work to top right. Okay, now if it's negative, it's going to start top left and work down to the bottom right. So it's a flip, if you will. So you can sketch cubic graphs in a similar way to quadratics by considering their solutions or their roots. So you should also find where the graph crosses the y-axis and consider the general shape of the graph as well, which is why I'm just showing you those two pictures. So here's an example. Sketch the graph of this function here. Y equals x minus 2, x minus 1 and x plus 1. So if y is 0, then I get x equals 2, x equals 1 and x equals minus 1 by solving each of those brackets simultaneously. So I get minus 1 0, 1 0 and 2 0. And if x is 0, well, I just sub in 0 and I get y is equal to 2. So I get 0, 2. So I've got 4 points that I know are part of this curve. So I've got minus 1, 1, 2 and the 2 there plotted. If you multiplied the brackets out, you'd get the x cubed as a positive, so the graph is increasing overall from left to right. So it's going to start in the bottom left, as a is positive, the coefficient of the a, in other words, which I was telling you about earlier. Alright, that's how I sketch that one. So here's another one. We've got y equals x minus 2, 1 minus x and 1 plus x, all multiplied together. If y is 0, I solve these, so I get x equals 2, x equals 1 or minus 1. So I get minus 1 0, 1 0 and 2 0. And if x is 0, well I get 0 minus 2, 1 minus 0 and 1 plus 0. So I get y is equal to minus 2. So I get 0 minus 2 as my fourth coordinate. So if you multiply the brackets out, the x cubed term will be negative, so the graph is decreasing overall from left to right. So it will start in the top left corner and work its way down. Here's another curve for you. We've got y equals x minus 1 squared times x plus 1. Now here we've got a repeated factor, so I'll have to deal with that in a minute. So if I put y equal to 0, I get x is 1 or x is minus 1. Okay. Which means I get minus 1 0 and 1 0. If I get x is 0, I get y equals 1. So I get 0 and 1. So I've got my 3 coordinates I can plot on my graph. Now, I've got a repeated root. Now, a repeated root is typically where the discriminant is equal to 0. Yes, equal to 0. Okay, so that is the b squared minus 4ac equal to 0. Okay. If you don't know what I'm going on about, that's what I'm going on about there. Alright, so if you have a squared bracket, the curve just touches the axis without passing through it. So you get a nice bump here on the curve. I'll sketch the curve with the equation y equals x minus 1 and x squared plus x plus 2. So if I put x is 0 and y is minus 2, I get 0 minus 2, and one root is at x equals 1. Okay, solving this bracket equal to 0. So I get 1, 0 there. Okay. So you could try factorising to see if there are any more roots from the second bracket. In this case, however, the discriminant is less than 0, so there are no more roots to that equation. Okay, so I plot my curve with the information we cannot. With the information we have, we cannot be sure about the precise shape. Okay, I should have a comma there. Okay. So remember, this is just a sketch with key points included. It doesn't have to be spot on. It's a sketch. All right. Hence the name, sketch in the question. Okay. So I want to move on to quartic graphs now. Now a quartic is something with an x to the 4 term. Okay. As we'll see in a moment. So let's crack on. So quartic graphs are of the form f of x equals ax to the 4 plus bx cubed plus cx squared plus dx plus e equals 0, where a, b, c, d and e are real numbers and a is non-zero. So a quartic equation can take a number of different forms depending on its exact nature. So it can have up to 4 roots and up to 3 turning points. Like so, where a is positive, a is also positive, and a is negative. So I've got many different shapes here. So I've got a repeated roots here as well. So I'll sketch this curve, and there will be roots where x equals minus 1, minus 2, 1 and 2. If you sub in x is 0, well then I got y equals 4. So I plot on the curve and I label what the name of the curve is, and drawing it nice and neatly with a pencil. Remember, with graphs for any exam paper you must go back over it in pen, because it won't pick up the pencil when it's scanned in on the scanner. Alright, so just be careful. So here's another one. So there will be roots where x is 0, minus 2 and 3. The root at minus 2 is repeated, and if x is 0 then y is 0. So it's going through the origin, and I get this lovely curve and the repeated root at x equals minus 2 over there. Nice and simple. Here's another one that I've got double repeated roots here. So there'll be repeated roots at 1 and 3. If x is 0, so I get minus 1 squared, which is 1, and minus 3 squared, which is 9. So 1 times 9 is 9. Okay. So I plot my curve, and I get those 2 repeated roots here and here. Alright. So reciprocal graphs then is things that will take the form y equals 1 over x. Now 1 over x, from your index laws, you can write that as x to the minus 1. Yeah? So it's looking at those shapes of graphs. So you can sketch graphs of reciprocal functions such as y equals 1 over x and y equals 1 over x squared, and y equals minus 2 over x by considering their asymptotes. So sketch the graph of the function y equals 1 over x. Table of values can help here. Okay, so you can't divide by 0, so you get no coordinate when x takes this value. So I get this lovely curve. In the example to the right, the asymptotes are the x and y axes as the graph tends towards these but doesn't reach them. Definition of an asymptote is it gets closer and closer, so the graph is approaching x and y but never touches it. Okay, so it's getting closer and closer but it will never touch. So it's kind of a bit of an exponential kind of curve going on here. So their equations would be x is 0 and y equals 0 for the equations of those asymptotes. Okay, so y equals 3 over x, the curve will be the same as the previous one but further out. Okay, so y equals 3 over x is in the blue there. Y equals minus 1 over x, the curve will be the same, but this is reflected in the x-axis. So I get that in the blue. If the equation contains an x squared, this will mean that all values will be positive, assuming that there's no other parts to the equation, right? So think about what the graph will look like. So y equals 1 over x squared, summing in a couple of values, and I get this curve, y equals 1 over x squared. So, points of intersection then. Getting closer and closer to the end of this video. So, you can sketch curves to show points of intersection and solutions to equations. On the same diagram, sketch the following curves: y equals x times x minus 3, and y equals x squared and times 1 over 1 minus x, let's say. So, first thing, I've got a quadratic U shape, and it crosses through 0 and 3. For the first curve, like so. And the second one is a cubic negative, and it crosses through 0 and 1, and the 0 is repeated. Like that. So, to find the coordinates of the points of intersection, I want to set the equations equal to each other. Like so. So it's simultaneous equations, essentially. Okay, so when I solve that, and I get x is 0, and x is equal to plus or minus 3. And to find the y values, I just sub those in. Nice and easy. I find these coordinates of intersection. On the same diagram, sketch the following curves, like so. So I've got a reciprocal now. And it's a positive reciprocal, so it doesn't cross any axes. Okay, it just tends to them, like so. So I can put the two together, and I can solve that. So translating a graph then, if I substitute in these points and draw curves of them, we can see by just adding the 1 on the end that all the points are shifted up by 1. So it's translated the graph up by 1. So we get the same original set of values for y, but they've all increased by an extra 1. Now the only difference here is that when I put it inside the x, it's translated 1 unit to the right. Even though it's negative, it's going to the right. So you do the opposite of what you expect, as you'll know from GCSE. General rule. The graph of y equals f of x plus a is a translation of the vector y equals f of x by the vector 0a. And the graph of y equals f of lots of x plus a is a translation of the graph y equals f of x by the vector minus a0. Alright. can have a go at sketching those curves, and here are the solutions to those if you would like. Nice basic, bit of practice, of course. And these are various functions that you can see. Also, asymptotes are given by a dotted line. So this is the transformation bit, by just changing it. Not much to do here, so I will skip this bit, because not much to look at. I think only that is important, so I'll leave that up for you to have a read, and then we'll crack on. But nice and simple. Okay, I'm not going to go through these because these are in the textbooks, and I'll leave it up there if you want to read them. There we go. These are just tons of examples and questions you can practice yourself. And then transforming them. Function. And that's the end of the video. So not much in these last few sections because there's not really much to go through. Speaking wise, it's just a lot of reading and a lot of drawing. Pretty much. Make sure when you're doing this video you got a ruler with you. And that is the end of this video. So make sure that you hit the like and subscribe to the channel if you want to have see more videos from me on the A-level course, as well as my GCSE to A-level transition, which I'm doing over the summer, as well as these videos. So there's lots more to come over the summer, and hopefully you'll be joining me for that. So thanks for joining me. I know this video has been very long, and I shall see you next time. So see you in the next one. Math Boy out of here.